So hello everyone and welcome back to the channel. So this will be our last video for OP, MLP OP, and this is the fourth PYQ from the sheet that is given in the WhatsApp. So yeah, let's start. So firstly, this is your collab. You'll have to just upload the files here. That's it. And then get them here using pd.read CSV. That's it. Okay. We're not gonna go with all this. Okay. You'll get the metadata like this. What the data says, what each column is represents, etc. Then you'll have to say which data set you are using, etc. etc. Okay. First question is what is the average of the flight ticket price? Okay. So you obviously have this column here, price column. You can see from df.info or you can just read the metadata. Both are same. You have to write just find the average of that. So I just did price and just did mean. That's it. And it has set up to two decimal places. I have done three. Yeah. So, anyways, next is this is not important. How you are getting this is important. You can just see those three decimal places. That's it. During which month did the highest number of flights occur? So obviously, first we need the month. Okay. Months are represented by numerical codes. January. Okay. So basically, months are encoded as 1, 2, 3, 4, and etc. So what we can do is we can just apply on month. We can just apply dot value counts. Okay. So give the it will give you how many value counts are there for each unique value. So let's say if January is 1, then it will give you value counts for January as a value, and similarly for February and etc. I've shared this collab in the WhatsApp group, so you can just try things on your own also. Then I have just done ID max. ID max returns the index of DF. Okay, so basically, if there is a column called 1 and then there are the value counts. Okay, so like this. If there is 1 and let's say the value is 4. Okay, so id max will return 1. Okay, let's say this is the first entry and the uh, second entry is uh, 6, let's say, in the same data frame. Okay. So id max will return id x max will return 2 because this is the column. Okay. This is the key basically, or column, whatever you want to call. And argmax will return 1 because this is the index of the max value, which index the max value is present on. So that is the difference between idx max and argmax. Uh, Next is what is the average price of flight tickets higher on weekends, Saturday or Sunday? Okay, so basically you have to check if the average price is greater on weekends or on weekdays. Okay. So first for that we need weekdays obviously. So we have just created a data frame where we are storing the prices of the of flights on weekends, and then we are finding the mean because we have to calculate the average price. So that's what we have done here. And then weekdays. Okay, this is weekdays. Not I have just used a variable. Don't go over the meaning naming. Okay, so I have done the same thing. Like this thing, I have just copy pasted here. But I have just did this tilde. This tilde is basically you use negation in normal Python. You use negation is equal to exclamation mark, right? Like exclamation if true. So you just do exclamation of that. So it just becomes false. Okay, so it will return the opposite of that. Okay, so here instead of this thing we use tilde. That's it. That is a negation here. That's all. So this is basically saying first find all the weekends flights and then do negative. Basically meaning all the flights that are not on weekends. So basically meaning flights that are on weekdays. And this thing is the same. After that we are just doing max. Okay. And here I'm doing argmax because I want to know which is greater, weekends or weekdays. So since it is giving 0, we have 0 on weekends on 0. So that's why weekends is higher. Okay. 0th index is equal to WT, which is weekends. Okay. And this is doing the same thing. You just need to see. I've just added max here. Same thing. Okay. Now you have to see two of the entries in additional info column are no info and in no info. Okay, so basically, if you see the additional info, you have two columns with the same name, no info and no info. Just one is a small I, one is capital I. Okay, so it is basically asking you to convert them into one no info column, which is basically uh, uh, which you have to columns are not enough, replace all occurrence of. Okay, so basically smaller one you have to retain. So this plus this, that's all you have to do. So you can just use the replace function. Replace can also take a dictionary, so you can just give which value to replace with what value. That's it. So all the no info will be replaced with smaller I. That's it. This is how you do replace with a dictionary. Okay, and you can now check. This is basically for checking. Before we had two no info, now we just have one no info, and the values have gotten added. 7353 plus 3 7358. So 7378 plus 75 plus 3 is 7378. Yeah. And after that, it is asking how many flights fall under airline Indigo and have no info. So just apply a condition that DF at airline is equal to Indigo and additional info is no info. And just add the shape so that you just get the rows at last. With the Yeah, you can just do shape also, then you will get the rows comma columns. That's it. Nothing else. Okay. Now convert the value of duration into seconds. Okay. So see, duration are like this. Okay. This is not numerical. You can't like access this. Okay. So you have to we have what we have to do is 26h. We have to convert this to hour, and we have to everything to basically seconds. Everything to seconds, basically hour to seconds, and then minutes to seconds, and then add them. So basically, it will have something like a nine, whatever the value is, 9600, I guess, something like that. Um, Whatever in seconds. Okay, that's what we have to do. So what we have to basically do is we have to split first the hour and the minute. Okay, we have to replace these. Okay, and then we have to multiply the hour with 3600 and minutes with 60. So the solution that is given is using str.replace. Str.replace is for replacing one by one. Okay, so first it will replace the h with 3600 and m with 60. Okay, I'm just taking the first example, but everything will be same for all others. M with 60. Okay, and then it is replacing this space in between h and m, this space with plus. Okay, so basically it is returning this thing. Okay, okay, and then it is doing pd.eval. Pd.eval basically just will evaluate this string. Okay, this string it will evaluate as a basically an evaluation. So it will just do 26 to 3600 plus 35 to 60. Okay, this is the first method. It is given in the solution, but I have done it a little differently. Basically, first I have done a replacements dictionary. I will basically using dot replace. So I have just added h to be into 3600. Basically, these three things. I don't want to write three things. I just want to write one thing and do it. Okay. So I have just done these things into a dictionary, and then I'm passing it. I'm just storing it in a variable. You can just directly do it df at df1 duration and just add it. Okay, but I am for explanation purposes I'm just saving it as a different variable. So what I'm doing is, firstly, uh, I have the dictionary now. I'm passing the dictionary to replace, and I'm doing regex is equal to true. Okay, why do we need regex is equal to true? So if you are doing regex is equal to true, keys are interpreted as regex patterns. Okay, not normal things. Okay, so what this helps us doing is, if you don't have this now, so it will match only hm. Okay, so else needed hm exactly. Okay, if there is h and m, then only it will match that. Okay, else it will just skip. But there is h here, then space, then something, then m. H and m are not together. The same with any space also. So that's why it will give error if you are not having the regex is equal to true. If you have learned, if you have done SC, you will understand it better. Regex is equal to true. But basically, keys are interpreted as regex patterns, can replace H and M in one string. Okay, so basically, it will, wherever H and M are, it will be replaced regardless of their position if you have regex is equal to true. Okay, just do regex is equal to false. Copy this notebook, regex is equal to false, and then try it, and then ask GPT if you have more doubts. Okay. Next, I have just done this, and then same thing, this line basically. So I've just done df on duration, and I have passed this series and just done dot apply. So now I have all the strings. After this step, I have basically all the replace. I have these things for every row. Okay, like this. So I'm just doing pd.eval for all, and at last I have to find the mean. So that's what I've done. Okay. Next is apply the following functions to the column. departure time and arrival time. Okay. So there was a PYQ which we did, and we used PD dot cut there. Okay. We can't use PD dot cut here. Why? Because see, PD dot cut wants the needs to bins to be increasing in monoticity. Okay. So basically what that means is 5 get 5 then 12. Okay. 12 17. This is fine. 17 25. Okay. Because 12 greater than 5, 17 greater than 12, 20 greater than 17 is fine. But it will fail here. 20 is less than or equal to 5. So it will not pass here. It will just give you error. It needs to have a continuously increasing bins. Okay. So we can't use a PD dot cut. So yeah, this is the most, like, this is the easiest I found. Like, there are ways other than this that you can do using dot condition and dot subspace or something like that. I forgot, but yeah, this is the easiest. You just define a function first that you have what you have to do. Okay, after that, this is for just for checking. You can just ignore this. Okay, now see, arrival time and departure time are not directly okay. Like, we cannot just apply because we need the hour. Okay, so we have to extract the hour. See, in our arrival time, this is the hour. Okay, in departure time, this is the hour. So first we need to access these hours. Okay, so the departure time, we have just applied a function, and this is a lambda function. What it is doing is, see, for 20 is to 20 0 0, what it will do is first it will split on the uh, colon. Okay, so since it splits on the colon, you will have two entries, that is 20 and 0 0. Basically whatever there is before the colon and after the colon. So we need the hour, so we are extracting the 0th index. Okay, so now we have 20. After this, I'm just explaining for one, you will, this will have be same for everyone. So with from here it will get 20, from here 16, from here 90. Okay, now we have to do the same for arrival time also. So we have done the same thing, literally the same function, just the column name has changed. Okay, after that, we just need to apply the function. Okay, so now we have, basically our departure time will be 20, 16, 19, 18, 17, and here we will have for 4, 19, 21, 1, whatever. Then you just need to apply the function on both, and go them morning, afternoon, evening, night. Okay, that's all that it has done. Okay, after that we are checking. See, now arrival time and departure time both are encoded. Okay, so now now we just need to check flight started in morning, arrived in evening. So you just apply the condition on departure time as morning and on arrival time as evening, and just find the shape. That's it. Okay, now again, for encoding, we have to encode the values of columns weekday as follows. So all weekends will be 1 and all other remaining days will be 0. So you can just, like we saw above, replace can take a dictionary, so we are just gonna pass a dictionary to it. Df and weekday dot replace, we will just pass a dictionary for each day to be encoded as whatever their value is. Saturday and Sunday will be 1, Monday, Tuesday, Wednesday, Thursday, Friday will be zeros. That's it. So we have just passed this dictionary to that, and we have applied it on the weekday column, and you can see the sample and you will see these are encoded. So after that, we have been asked what is the frequent mode of weekday. So we can just do weekday dot value counts, or we can just do dot mode, whichever you want. Whichever you want. So you can just see that 0 is the 0 is the max. Okay, so and 0 represents weekdays. Okay, 0 represents weekdays. 0 represents weekdays. Okay, that's it. That's all you had to do. Next is just simply train test split. Okay, I'm not going over this. It's simple. Okay. So now we have to apply pre-processing. Okay, this is like, I'll go slow. This is important. Okay, these are whatever you can just go through this. Okay, this thing. Okay, see, first we have been set to impute the missing values in total steps with the most frequent value. Okay, so I have first used the column transformer to impute. Okay, just for imputer. Okay, I need first to impute and then I'm gonna order an input. So I'm not gonna give all of them in just one. Okay, because I am in I will be ordinarily encoding total stops also. So first I am gonna have two different column transformers. Okay, so first I have done this. This is simple. I have been over this a lot of times. Okay, here comes the main part. Okay, see, we have airline, source, destination, additional info, total stops, all of them to be ordinary encoded. Okay, these four will have default categories. Okay, airline, source, destination, additional info will have default categories. Okay, so just focus on this line first. Okay, so I have just done nothing, but I just defined an ordinal encoder with the values that are given. See, if unknown values occur in the test data set during transforming it, handle unknown values by replacing with -1. Okay, so that's what I have done. Handle unknown is equal to use encoded value. Basically, if you handle unknown as use encoded value, ignore some and a few more, but the most two important are ignore and use encoded value. So if you do ignore, it will just ignore the ignore the unknown values as they are, and then uh, if you use encoded value, then you'll have to give a value that will be replaced for all the unknown values. So since we have been given that -1 will be the unknown value now, so we have just given that, and we have passed all the columns on which we need to apply this. Okay, these are given. Sorry. Next see. Okay. Next, we have to encode total stops with these categories, departure time with these, arrival time with this. Okay. Now you can have three extra. You can just define it into different steps. Okay, like they have done here. Okay, they have encoded each one as a different steps. Okay, like here it is defined for total stop and then departure time, then arrival time. I have not done it like that. I have defined one because ordinal encoder, it has a parameter called categories, which takes a list of lists. Okay, it will take a list of lists. See, these are three lists inside one list. Okay, so categories basically takes a list of list. Okay, so you can just give a list of list and give the categories. Okay, so non-stop, okay, is the total stops. These are the categories for total stop, these are for departure time, and these are for arrival time. Okay, so I have created three lists and passed them to categories, and then this thing is the same as above, but now how you apply in here, the columns matter. Like someone has asked yesterday that if the column numbering ordering matters. So in this case it matters because since you're passing a list of lists, obviously the first one, the first list will be applied to this, and the second will be applied to this, and third will be applied to this. So in this case, the column the ordering of columns matters. Okay, so yeah, that's what we are doing. So now these will be applied to encode total stops, these to encode departure time, and these to encode arrival time. Okay. So now we have done till here. Okay. Now we have done till here. Last we have to do using min-max scaler to scale duration. Okay. So now we are defining one more because we have to do scaling after these are ended. So we are defining a one more column transformer with scaling. Okay. Okay. Yeah, scaling, and just we need to scale the duration. Okay. Okay, that's it. So now we have all the steps that we needed. Okay. Now here you have two ways to do it. Either you can call fit transform on train and test transform on test explicitly for each column. Sorry, explicitly for each column transformer. Like you will have then three steps. Okay, or you can just use a pipeline for sequential execution. That firstly it will have this, then it will have this, then it will have this. Okay. So how you define a pipeline? You just say pipeline, and then pass a list of tuples. First, this is just a variable name. You can give anything. I've just given impute. And so firstly, what it does is, firstly, it will end the like complete this column transform, whatever it is happening, whatever it is doing, it will do it complete. And whatever the output is of that will be passed on to this. Okay. And similarly for this. Okay. So basically this will execute, whatever the output is will be passed to this column transformer, whatever the output is will be passed to this column transformer. That's what pipeline is doing. If you write pipe, you can see the pipeline. Okay. I'm not expanding this, you can just see. And this is the solution that was given. You can also check this. But I have just done directly extend TF is equal to pipe dot fit transform and extend TF is equal to pipe dot transform. Okay. That's it. You have done the pipeline. You have done this. Don't get scared after saying all this. These are basically simple things. You just need to write. There's a lot of coding. That's all. Okay. Now we have to see what are the sorry, were any unseen values present? But basically, did we need to use the -1 thing? Okay. Did we ever need to use this? Okay. So for that, you can, the simplest way is this only, that you just check whatever in columns you have transformed. Okay, you can see whatever columns you have transformed here. Okay, you have done total stops, airline, whatever. Just pass them here for column in this, and just check if -1 is present. We have been asked for the test data set, so we are just doing x test column dot values. Okay, so obviously we need the values. We need because -1 will be in values. Okay, so we are just accessing the columns, and then we are accessing their values. And if even a single -1 is present, we are printing yes. That's it. This is the simplest way. There are other ways, but this is the simplest. After transforming test data set, all is entry. Basically, they have asked us the max highest value present. So highest value you can just do max dot max dot max. Basically, this will return the maximum value for each column, and we are then again maximum, so it will give the final maximum value. And similarly, instead of maximum value, we have just been asked the mean, so it will be dot mean instead of dot max. And we have been asked the highest value observed when scaling the duration. We can just do x duration dot max. Okay, highest value. Remember highest value. So you need the dot max. So that's it. You just got the final answer. So this was a pre-processing. Pre-processing was tougher in this. I've explained it fully. If there are still any doubts, you know my WhatsApp. You can just even comment itself. Next is model building. This is really simple. This is the same things we have been doing for the last few IQ. You just need to get the data set. After that, drop whatever you want, whatever given. You can just drop these. Then we just need to train a reg model. So we have done reg. We have trained the model. We have fed the model, and we're just finding the R2 score. That's it. The answer was like 3 decimal places, so that's why I rounded to 3. That's it. After that, same thing as SGD regressor with grid search CV. Since there is grid search CV, we need to define a parameter grid. So we have just imported these two. Then we have defined a parameter grid. Then we have just given the parameters, penalty, alpha, tall, whatever the values are given for the hyperparameters, we have given them as a dictionary. As a, yeah, and then we have just done. Okay, that's it. And then we are training. What is the best penalty? We can just access the best parameters, and it will return a list of. Sorry, it will return a dictionary with the best parameters. We can just check. Best penalty is L1. That's it. We have just been asked the mean absolute error, so we can just instead of R2 score, we can just add mean absolute error, and that's it. Common instruction for 5 and 6. Same thing. Instead of SGD request directly, we need to train a pipeline which has two steps in it, and then we need to pass it to Gritzel CV. So there will be two things here: PCA, lasso, and then which will be a pipeline. These two will be in a pipeline, and then there will be Gritzel CV applied on that pipeline. So you can just do define a pipeline. There are no parameters given to be given to the estimator and transformer. We just have been given the hyperparameters, so we train them. And how is the naming convention? You first give the variable name and then double underscore and then hyperparameter name. So we have done that. We have trained. That's it. We have just been asked to find the R2 score. Okay. Here, how much variance is explained. Okay. So we have been doing it like this. Okay. But I learned that you can just access the best estimator at 0. Okay. What we have been doing is we have been accessing the grid first. Papa. First we have been accessing the grid. Sorry. First we have been accessing the grid search CV. First we have been accessing the grid search CV, and we are accessing the best estimator of that. And after that, we were accessing the name steps of the pipeline because best estimator will be a pipeline, and then we were accessing the name steps and then accessing the PCA. Okay. So because this is the way we have been doing, and then we are just since we are now in the PCA, we can just call the explain variance, and since we have asked the we have been asked the first principal component, we have done the 0. Okay, access the 0th index. But this was the method that was given, and this is also good. I didn't know this was happening, so this could have been done. Okay, so we are first accessing just the same thing. So the part till here is just the same. After that, instead of dot name steps, we can also access by the index. Okay. So since best estimate will return you a list of. Okay. So at least the PCA will be a 0th index, and for LASA will be first index. Okay. So since we need to access the explain variance, but which is a PCA attribute, so that's why we have done at 0th index, and rest this is again same. So you can use both ways. Okay. Name steps. I didn't know this, so I was explaining by this, but yeah, this can also happen. Okay, cool. After that, we have to basically make a pipeline with poly and lasso, and same thing. We have been given the parameters that we need to give, so we just define it itself. Okay. and then train it. That's it. And we need to find the R2 score. I think R2 score code got deleted for some reason. Uh, Now we have to round to 3. R2 underscore score. We just pass y underscore test, and then what is the name? Pipe dot credit, and we pass extras. Oh, we have to run the everything. Ah, oh, why you don't even need this code? Why is this thing? Just run off. That's it. It will take a while, but yeah, this is the code. So, yeah, it will take a while because we have a lot of. Okay, it is already reached here, so it will not take a long now. Yeah, 0.5 to 4. Okay, now you can also access. Since we have pipe, we can just access pipe dot name steps to check the steps of this thing. If we do this, you can just see this. Okay. Uh, yeah, you can also do pipe at 0. Okay. You can't do pipe at PC. Okay. This thing you can't do. Sorry, I'm calling. Okay, you can do this also. Okay, so then in the new version it has been added, but in the previous version you couldn't do this. Okay, so now you can do this. Okay, never mind. You can just same thing for column transform also. So now the column transform and pipeline both have the same accessing condition. In older versions, in like 2022, 2023 versions, the pipeline was not able to access these directly. You needed to do that. You needed to do dot name steps. Okay, and then access. That was the whole point of defining it using pipeline itself. Okay. But since you can now define using now access using that, you can just use dot make pipeline. Okay, instead of just pipeline. Okay. But yeah, you have been doing it like this. Just remember this. Just add one more thing, that you can just access the elements by index itself or just by name itself without having to access dot name steps. That's it. That's the new thing that has been added to the newest version. That's it. Okay. So yeah, I didn't know this too. I something new. You learn everything. Okay. Yeah. So yeah, that was the week. Sorry, that was the fourth PYQ, fourth sheet. With this, we have completed 6 PYQs in total. Yeah, I have shared all the collabs in the group, MLP group, and yeah, that was it. Thank you for joining. All the best for the exam.